Welcome to another lesson of our Eduonix series, Learning to Program with Python 3. In today's lesson, we're going to be talking about objects. They're a really core concept of the Python programming language and programming in general. And we're going to talk about how they allow us to store information in a more complex way that models what we see in the real world. So far, we've been using variables to store really basic pieces of information, things like numbers, sets of characters, and lists. And we can store collections of data, and we can even relate data with the data structure that we talked about, like dictionaries. But in the real world, you're going to have situations where you want to write a program to model something that's a little more complicated. You want to have a bunch of information belong to something else, basically, and be able to perform some actions with whatever that thing is. And that's where objects become really important. So objects have what are called properties and methods. And properties are basically variables that are attached to objects. So an object is this sort of holding container for a bunch of information and a bunch of actions that you can take that are all related to something specific. So we've actually been working with objects already without knowing it. Basically everything that we've looked at in the Python interpreter is an object underneath, and it does have properties and methods. And now when we open the Python interpreter, we're going to take a look at how we can actually access those properties and methods and what they mean. The properties are pieces of information that are stored that describe our object, basically like attributes concerning that particular object. For instance, a list is an object. And one attribute of that list, a piece of information that's important to store alongside of that, is how many elements are in that list. That could be really important if you need that information in a program. And a method is a way that you can perform some functionality on the object that you have. In the same example, how talking about a list, we've looked at declaring lists with a bunch of predefined values, but say you want to add something to a list or remove something from a list. A list is an object, and there is a function called a method that belongs to whatever list that you want to call it on that allows you to add or remove something from a particular list. So to get a better idea of this, let's take a look at it in the Python interpreter. Alright, so I'm going to open a Python interpreter to try and get a better look at some objects that we've looked at already without realizing it. So I'm going to create a list first to kind of demonstrate some basics of objects in Python. So lists are objects, and like we talked about in the slides, objects have both properties and methods. Properties are basically information stored alongside a particular object. We're going to call a function that allows us to access a particular property of this list. In this case, the length of the list, how many elements are inside of it, is a property that might be stored alongside the particular list. So there's a built-in Python function that allows us to see that property. That function is called len. So we're going to call that and get back a piece of information about this list telling us how big it is. Now this isn't generally the way that we access properties for a particular object, and we're going to look at the more general example in a minute. But this is just an example of seeing that there's information stored alongside a particular object. That's not just the information that's contained in our list, for instance. In addition to having properties, and we'll sort of explain the properties as things that describe the list, information about it, objects also have methods, which are basically functions that are attached to a particular object. Functions that perform some action with or on the object that you call them on. So one way that we look up elements, or basically what we call members in object-oriented programming, things that belong to a particular object, in Python we use a dot. So we will use a variable name, which refers to the object, dot, whatever you want to access. And that can be either a property or a method. So we can use this syntax to kind of get at a particular method or property of an existing object. So we're going to talk about the append function. And that's a function that allows us to add an extra element to a list. And unlike most functions, we don't have to pass the list as a parameter like you might think. We can call this function using the dot notation directly on the list that we have. So let's take a look at how you would do that. We have a list 1, 2, and 3. If we want to add the element 4 to that list, you can use the name of the list dot append to add an extra element. So it doesn't return to us a new list. The same list that we had before, that object has been modified. And we can take a look at now what value is stored inside of X. Now the list contains 1, 2, 3, and 4 instead of just the first 3 numbers that we initialized it with. So this is kind of example of methods. We have functions that are attached to particular objects, and when we call those functions, that function performs some action on the object itself. In this case, we've added an element to the list. We can also remove an element from a particular list. There's also a method on the list object that allows us to do that. It's called pop, so let's call that. Pop will actually return to us the value that it's removed from the list, so we'll see that. As you can see, it removed the 4 that we just added to the list, and now when we look at X again, X is now just 1, 2, and 3. So even though we haven't reassigned X by changing what list it is, essentially, saying X is equal to new set of brackets, new set of information in that list, we've actually been able to modify the object that X is and add some values to it and remove some values to it. So this is an example of how methods can operate on an object. Let's look at another example to kind of get a better understanding of what that might mean in a real-world context, outside of just the data structures that we look at in programming. So one really helpful way to understand objects might be to look at them in terms of real-world applications. So in this example here, as you can see, we have a car, and it has methods. These are the actions that the car would perform. So these are what the functions that are going to be associated with a car object that you might run into. In the same way, it has properties, things like the color, the model of the car. These are information that's stored alongside a particular car object, but they're different from methods. They don't perform any particular action. We can actually take a look at an example of what this class might look like in Python and how you might access these attributes and methods. So what I've done here is loaded an existing Python file into my Python interpreter session that allows us to create car objects like the one that we just talked about. So we're going to talk later about how you can create your own objects and what the syntax necessary for that is and kind of what's important about that set of the Python programming language. But just to get a better understanding of how objects work, we're going to talk about a few things in terms of how we can create new objects and how we can look at properties. Slightly different than the way that we looked at the length property of a list. And this is the more general, typical way that you'll look at properties of an object. So first, we have to create an object. So in order to create an object of any type of object, you need to call what's called a constructor function. And so we talked a little bit about types, but basically the constructor function kind of looks like a function call involving whatever type of object that you want to create. So we've been talking about the really basic types like int, list, and string. And since these are objects, you can actually create new versions of these, or rather create new objects by using the same syntax that we're going to talk about. So we can actually look at that syntax really quickly. If we want to create a new list, we know that the type in Python is list. And then we add the function call parentheses to the type, and it creates a new list for us. So this is a way that you can create new objects, and this actually works with any type. You can create new strings this way. And as you can see, it's just a new string. We can add characters to it if we want. We can check the type. And we see that it's a string. So basically, adding a function call like syntax to any type will create a new object of that type. And when we talked a little bit before about converting between data types, that's actually what was going on, is we were using this syntax and passing it something of a different data type, and it was creating a new object with the correct data type. And that's actually how we convert between data types in Python. But for other classes, ones that are not these built-in types, like list and string, we also use the same syntax to create new objects. So let's create a new car object, and we're going to, this isn't in Python by default, this is something that we've created here for an example, and we're going to later talk about how you can create this entire object for yourself and make sure that you can create your own instances of it and define what other methods and properties you want of it. So we're going to create a new car object, and when we use the syntax, we say that we're creating an instance of the object. And we're going to talk a little bit about what that means more when we get into classes. But so now we've created a new car, and our new car has properties, like we were talking about before, that we can access with the dot notation. So instead of using function call syntax, we just use dot, the name of a particular property we know that a car has, and then it'll return to us the value of that property. And we can use that however we want. But basically this property is used to describe some information about the object that we have. And you can usually set or change that property. A lot of times when you create an object, you'll pass in values to that, what's called the constructor call, when we create the new object by adding the parentheses to the end of the type. When we do that, we can pass in some parameters, and we might use those parameters to set properties on a particular object, like in this case how we just accessed color. And in addition to that, we also have methods in the same way that we looked at in the picture before. And we have all of the same methods that we had when we were looking at that image. We can call them all. So as you can see, these are the methods that are attached to our car object. We have properties that are also attached to our car object, and these pieces of information are all stored together in a place that we can access them. So that's kind of the basis of how you interact with objects. You can call functions on them that are called methods, and they also have properties that you can access. So we're going to wrap up this lesson here and start talking in the next lesson about how we actually create objects and where the descriptions for those properties and methods come from. So that's it for this lesson. Welcome to another lesson of our Eduonix series, Learning Programming with Python 3. We're going to continue our discussion of objects and programming with objects by talking about classes and how they're really deeply related to objects and how we can use classes to describe our own objects. So in the last lesson we talked about objects and how objects are ways to relate a bunch of different pieces of information and sets of actions that we call methods to a particular piece of information. Like, for instance, a list has properties like how long it is. These are information about the list, not just what it is. And then it has actions that can be performed, like append or pop, putting elements in or removing elements. Likewise, we also looked at the car example, which is a little bit simpler, which has properties, again, like the color or model of the car, and actions, things it can do, like drive or start the engine. So now that we have an understanding of what objects are, we're going to talk about how you create objects, because in the last lesson we only really looked at objects that were already existing or objects that were built in. So objects are ways to describe related sets of information and actions about particular information, anything that you want to represent. And so in order to create objects, we have to write what are called classes. Classes are the descriptions of objects. So classes are where you store the functions and the ability to store the particular properties that you need And then when you create what's called an instance of the class by calling that constructor function, using the name of the class, like we sort of looked at a little bit in the last lesson, you have what is called an instance of that class, and that's an object. And then with the object, you can call the methods on it, and you can access its properties, and you can do all of the things that we looked at in the last lesson that you can do with objects. So classes are the ways in which we describe objects. So on our example on the right, we have a really simple class. We're going to eventually, in this lesson, build up the full car class that we looked at using in the last lesson. But before we get into a lot of the specifics, let's open a Python interpreter and look at some of the basics of how we can create really small classes and what all of the things in this example mean. So, in order to create a really basic class, you start with the class keyword. And you specify a name of the class. And this isn't mandatory, but generally in Python, when you're specifying a class name, you start with an uppercase letter. So, and then you can use a colon. We'll talk about sort of in more detail why we had that object within parentheses next to our class a little bit later. But for now, this is the basics of how you create a really simple class. So after you have your colon, you can put whatever kind of information that you want to relate to the class. So any variables or functions that you define inside here will become part of your class. So we can define a variable. And so one thing that's important to note is the difference between classes and instances of a class, the objects. So variables that we define just within the class themselves, like this, color is equal to blue, will stay the same for every single class that we create. And this can be useful in a lot of cases, but it's not always the behavior that you want. A lot of time, you want variables to be individual to each instance of the class. For instance, using the car example, we might have one class that describes a car, but you don't want all cars to have the same color in the way that we just defined it here. In the way that we just wrote this code, every instance of the car that we create will have the same color. So the way that we change that is with what's called instance variables. And you can operate on instance variables generally within functions of a particular class. To write a method for a class, which is what we refer to as the functions that are stored within a particular object, and perform actions on that object, we write it the same as a normal function to start out. We use the def statement, but as a first parameter, we're going to use the word self. So what this means is, within this function, self refers to an instance of the class that we're currently operating on. So not the class itself. So remember, the class is this basic set of rules that describe every object, and an instance is one individual particular object, like a base set of rules for something, and something that actually enacts those rules. So when we change self, we won't change all instances of that class, we'll just change the single one that we're working on. So inside of drive, we can perform some actions. We're not going to operate on self here. We'll write some other function to demonstrate that. But say we wanted to be able to change the color of a car. And since we want the color of a particular car to be per instance of a car object, we're going to need to use a function that allows us to refer to the class instance. So what this will do is operate on the variable car color, and we're assigning that variable to whatever we pass into this function. So the self argument doesn't actually need to be passed explicitly. It is kind of what we refer to as implicitly passed. When we use a particular object, self is what that object, or rather, that object is going to be self when we use it within the function. So if we want to change that object, we use the self variable within the function, but we don't actually need to pass it when we call this function. So once we're done, we should have a car class within our Python interpreter, and we can create a new instance of that class. And actually, let's create two instances. So both instances of the car class, since we have a class level variable color is equal to blue, will have the variable color set to blue. We refer to having a variable at this level outside of an instance of the class at a class level. So it's global to every single car class will have this variable at that value. If you assign it to the instance like we did in the paint car function, when we access car color on my car, it's going to be red. But we can also change this for the other car and they'll be separate. So this is an instance level variable. It's something that's only common to an individual object of a particular class. So if you change it in one instance of a class, it doesn't change in the other instance. The objects are independent of one another. So as we saw from our Python interpreter session, the self parameter to all of your class methods needs to be there, but is implicitly passed. It refers to the object that this method is currently being called on. So if you want to add some functionality to your constructor, for instance, add a parameter and assign a variable when you're creating your object, instead of later using some other function like we did with the paint car method, you can define a special method that needs to have this specific name that will get called when you create the object, called double underscore. We use two underscores, then the word init, then two more underscores. This is a special function that is essentially your constructor. You don't have to worry about returning a new object or figuring out how that works inside of this function, but it will get called, and any parameters that you assign to this function will get required when you call the class constructor. So let's take a look at creating one of these on our car class. So we're going to create a new car class. But now we're going to create our init function. Init has to take self, but then you can add whatever parameters to it that you want. We're going to add the color parameter, so that when you create a new car, you have to pass in what color you want that car to be. And from here, we're going to assign color to the instance variable of the new object that gets created. So what will happen is, when you create a car now, it requires you to pass in a parameter specifying the color, and then once that's done, that object that you create will have the color that you specified during creation time. So let's take a look at what that actually means. So we can create new car objects like before, but we have to pass a parameter here. And the color attribute will be set appropriately. And we can do the same thing with a different instance. So now that we know how to create new class constructors, create class methods, and create class properties, we're going to duplicate the car class that we worked with in the last lesson, now that we know all of the things that we need in order to create that class. So we're going to start with a constructor. It needs to be the double init function. And then have self as a first parameter, like every single method we define for a class. Then we're going to pass in a color and model. And we're going to assign these variables as properties on our instance by using self dot and then name. So remember that the color without the self refers to the parameter being passed in, and self.color refers to a new property that we're setting on our instance. We're going to do the same thing for model. And we're going to start with an engine state. We're going to start with engine equals to off. We'll use that for our start and stop engine functions. So now we can create the rest of our functions. So we can create a function to start the engine, like we had in the last object lesson we were looking at. So we're going to first make sure that the engine is off when we're starting it. If it's not, we'll just tell the user of this particular object that the engine is already running. And then we'll do the inverse of that with stop engine. Otherwise, we'll let them know it's already off. And then we'll create a drive method for this car. We can also create a method that allows us to print out the details of a particular instance. And it'll work regardless of what those details are and regardless of the instance. So we just need to use self in whatever we call that method. So in this display car function, we print out the class properties that we've assigned earlier, and we also print out the state of the engine that will be assigned by either start or stop engine. So we can go ahead and load this up into a Python interpreter session and then start creating instances of car and using these methods. So starting Python3 with the -i flag allows you to load a particular script into the interactive interpreter. So since we defined our class in a file, we can load that script into the interpreter, and then we'll have access to that class so we can start creating objects based on it. So now the car class is loaded in, and I can create my own car. I have to specify a color and model. I can access the properties directly. And I can also call the functions that I've created. Well, there's no space in between is and off, but the string still works there. So we can start the engine. And that'll change the engine variable, so when we display the car again, we should see that reflected. And now we can drive it. So this kind of represents how we can store a bunch of different pieces of information and a bunch of methods within a particular class, and then we create instances of that class that we can then use these methods and properties with. And both of these things interact with the objects, not the classes themselves. So we're using a toy example here with the car, but there's a lot of real-world applications where you're going to want to store information like this through creating classes and objects. There's many programs in which you're going to need to store a lot of related pieces of information and specific actions based on that data type, and you're going to need to do those things over and over again. So classes and objects can be really helpful. So that's it for this lesson. In the next lesson, we're going to continue talking about classes and concepts like inheritance and overloading, and how we can apply that to the examples that we've looked at so far. Welcome to another lesson of our Eduonix series, Learning to Program with Python3. In this lesson, we're going to continue discussing classes and objects and how to write programs with them, and we'll take a look at how they can be helpful in organizing and designing our programs. We're going to take a look at some of the more advanced concepts in what we refer to as object-oriented programming. That is, the programming that heavily involves classes and objects and sort of interactions between them, and how we can apply some of these advanced concepts in our programs. We'll look at things like inheritance and method overloading. So let's get started and explain what those things are. So we've been looking at classes for a while, and by now I think we have an understanding that we can use classes as a way to kind of hold a set of information and actions that we can use to describe a particular object. And usually we use that to kind of represent some object within our program. We've been using examples with cars, but there's a lot of other applications. In any kind of program that you'd want to write, you can kind of use classes and objects to sort of model the information that someone is passing into your program and store it and kind of keep it related in a way that makes a lot of sense and is easy to understand. So we're going to talk about this concept of inheritance, and inheritance is a way for classes to get sort of new attributes and methods from other classes. When you create a class, you have what's called the ability to specify a class that it inherits from, and we call that class its parent class. So in the parent class, you can define some attributes and methods like you would on any other class, and then you inherit from that class in a child class, and the child class gets all the methods and attributes of the parent class. So we'll really quickly take a look at a simple example. Here in the code you can see in the last lesson we were looking at examples of a car class. And the code that we have on the right-hand side inherits from that car class, so it still has methods from the car class even though we haven't defined them. So let's take a look at running some code like this and making sure it works appropriately. Alright, so to get started working with inheritance, we're going to actually open one of the older car programs that we worked on before. So we previously had a class car that defined some methods and some instance attributes, things that were specific to the object. So let's see how we can inherit from this class. Generally, the way that we use inheritance is we can have something that's a base class, and then we use a more specific class to kind of add some additional information. So our base class might be car in this case, and then we'll have a specific kind of car that is our more specific class, and we inherit the base functionality of car. So I'm going to remove these instance variables. And I'm going to create a new class. And just like that, that's the way that we specify that our class is inheriting from the base car class. So, just as is, this class will have all of the methods and variables that a regular car does. And we can actually do this by creating an empty class, and we can do that like this. So on the next line, instead of writing any functions or anything, or just do an indent and pass. And this basically is telling Python, don't do anything here. You can actually use pass in functions in a couple different places. Any place you have blocks like this, where you indent, you can pass, and that's basically saying, don't do anything. So now let's load this into the Python3 interpreter and see what happens when we create an instance, or rather an object, of this Honda Civic. So let's create an instance of it. So there we go, we have a car. And it has the same functions that the base car class had, even though we didn't rewrite those functions or specifically include them. Like we can call start engine, we can drive, and then we can stop the engine. So, like we said, car is the parent class in this particular instance, and our child class, the Honda Civic, has all of the properties and methods of its parent class. So we can see that in this way, any attribute that we add to the parent class, we have in the child class. So let's go ahead and go back and take a look at the code. So now, if you want to add anything specific into our Honda Civic class, we can actually go ahead and do that. So we can add something that isn't in our parent class, and even though we're inheriting, we'll get a specific instance of it in our child class. So we're going to add a class level variable. We'll add a few, some of the ones that we had on the instance before. And so now, in addition to having everything from the parent class, we'll also have these specific attributes that we have on our child class. So we can just really quickly take a look and make sure that that's the way that it works. So once again, we can create a Honda Civic. And we have the same methods, but also we have some extra variables that are specific that weren't inherited. So this is the basis of how inheritance works. We specify a parent class, and we basically get everything that the parent class has. So we've seen that inheritance allows you to grab methods or attributes or whatever you want from another class and bring it into a class that you're currently working with. So we have access to all of those things. But what if you want to specifically change one of the things that you've inherited? You might have methods that don't work specific to the use case that you want now that you've inherited a bunch of methods. So what you can do is what we call override the method. One example of this might be you have a car that you have implemented a drive method for, but now you have a specific car, like our Honda that we worked with, and you want it to drive in a different way. But you still want to be able to use the drive method. You want to have the same name. So now you can implement your own drive method that will take precedence over the parent drive method. So even though there's the same function in both classes, the child's class function is the one that's going to get called if you call it. And you can actually do this across chains of inheritance. It doesn't just have to be one parent class and one child class. So overriding allows you to change the behavior in a child class for something that is already defined in the parent class. So let's take a look at doing this with the car that we've started working on. So now, let's go ahead and start overriding some of the methods that are implemented in our parent class. So for instance, say that we want our car to start its engine in a different way. So we define a start engine method on our Honda Civic that is going to override the functionality of the car. So what this will do is when this is called, instead of looking for the method on the parent class, we have it now on our child class. And so we'll be able to call the rest of the methods on the parent class. For instance, stop engine will still work. It'll still actually stop the engine because they're both using the same variables. But now our specific start engine function is going to do something different than what the base car class does. So we can take a look at this really quickly. So when we start the engine, it is now calling the specific start engine function of the Honda Civic class. But when we stop the engine, even though we don't have a specific stop engine defined, it's calling the parent class's stop engine function. So we can use function overloading to write some specific functionality in a class that's more specific, but we can still fall back on the base functionality if we need to. And there's a lot of use cases where you'd want to kind of use a mix of some of your own specific methods, but still use a lot of things that the parent class has. So one thing that might be important that you might have a question about is, what if you want to do both? What if you want to also call the original start engine function and then add in some of your own specific functionality? And there's a way to do that. So let's take a look at how we can grab the functionality of the parent and then do something additional, instead of doing a complete override where we just change the functionality of a particular function call completely. So like we were saying, if you want to preserve the behavior of the original superclasses method, or the parent class as we were calling it, but also add some additional functionality to that, Python has a built-in function called Supra that allows you to basically refer to the parent class within your subclass or child class. as we've been calling it. So basically, the way it works is kind of exactly what you see in the example on the right there. In our specific child class, we call Supra, and then we add our initial functionality. So you call Supra, which basically gives you a way to access the parent class. Then you call whatever function you want to call. So in this Supra call, we're calling drive, but that is going to call drive of the parent class and not just our child class functionality. So in this way, when we run this code, if we call drive on our Honda Civic, both that drive and the parent's class's drive will get called. So let's modify our existing example to use a structure like this, so we can call both the parent class's functionality and the child class's functionality within the same function call. So this is our car program that we've written thus far. So what we're going to do is extend the start engine function so that it calls both the parent start engine function and its own start engine function. And this is actually really simple to do in Python. We have a way of accessing our parent class, a function that we call Supra that's built in. So Supra is really simple to use inside of the class. In our example in the slides, we looked at kind of an older way that also works for using Supra, where you pass it the name of the class you want to get a parent for and an object that also gives you a parent class. But inside of our class here, we can just use the Supra call like this. And from here, we have a way that basically allows us to refer to the parent class. So then we can go ahead and call whatever function we want. In this case, that's start engine. And now, when you call the start engine of our child class, both the parent and subclass will be called. So we're going to change the print text so we can kind of clearly see that these do different things. So what this function will do is use Supra to get access to the parent class, call its function, so it'll first print out anything that's here, and do anything that the parent class has to do. So actually, we don't need this line anymore. Because the parent class will take care of that. And then we can print out whatever additional functionality we want to add in our child class. So this should actually work pretty similarly to how it did before, with just the additional functionality we want in the child class. So we can go ahead and test this now by loading this file into the interactive interpreter. So we create an instance once again. And as you can see, when we started the engine, it called both the parent class's function and the child class. So in addition to executing whatever was in our parent class, we added some additional functionality, and we can see that the variables that we set are still set. So our engine is still started. We can actually drive. It'll work. And everything else works normally. So as you can see, Supra allows us to add some additional functionality with inheritance. So we can inherit some methods, we can override those methods if we want to change the functionality completely, and we can use Supra to get some of that functionality back and call a method of the parent class and include some functionality from that in our child class's function. One other piece of information that might be helpful to know is that inheritance doesn't just mean that you have to have a single parent in Python. You can have multiple parents and inherit multiple attributes and functions from multiple different classes. So let's take a look at what this actually means. So right now, our Honda Civic only inherits properties and methods from car. but we can create another class and have it inherit some properties from that class as well. So I'm going to create a new class called blueCar, which is going to extend car, or maybe let's just have it add an additional property that we can see. And let's delete this line from the Honda Civic. So now we have a second class called blueCar that we can include in our inheritance list here. We can add a comment, or a comma, and add any additional classes that we want to inherit from, and then place it there, and we'll automatically inherit its properties as well. You can put as many classes as you want in this list of parents, basically. So you just use a comma, you put another class name, and it'll pick up the properties from that class. So now when we create an instance of our Honda again, we'll have the color attribute set to blue, even though we didn't specifically set it, because we're able to inherit properties from multiple classes. So we can look at that really quickly. So we create an object, an instance. As you can see, the color is still blue, even though we removed the specific line in our class telling it to make it blue. We can inherit properties from as many classes as we want. You can put a bunch of classes in your parent class list, and all of the properties and methods will show up in your child class. And you can also chain your inheritance as far as you want. If you were to make another class that adds some additional specific property on top of your Honda Civic, let's say you pull Civic out here and want to create another class that's just a Civic, and you can inherit from Honda, all of the properties will be added. So we can do something similar. So we can, as you can see here, you can chain the inheritance as far as you want. You can have as many children from an individual parent as you might want. And there's a lot of applications of this. If you want to describe more specific use cases like we're seeing here, we're narrowing it down to a general class of vehicles, starting from a general class of vehicles down to a specific color, down to a specific model, and we're adding more and more information with the classes. And you can use this to kind of specialize certain types of information so that you can know what it is inside your program when you're representing it. Because certain more specific types might carry additional information or do something a little more specific. So we can go ahead and instantiate this class and see that it has the appropriate model and all of the right functions that we've defined. So it has the right model and all of the right functions. It's using our same function from the original Honda that calls both the parent class and the child class, and then it has the rest of the functions from car. So classes can be really helpful for thinking about certain types of information we might want to store in our program. We can use the methods and attributes to kind of represent different things about our data, both its actions and properties, and we can use inheritance to represent more and more specific types without having to rewrite all of the information we store in our more basic classes, like we saw in our examples. So programming with objects is going to become really important as we start looking at some of the more advanced features of Python, because all of them, when we start using them, will use objects and classes in some way. So that's it for this lesson. Welcome to another lesson of our Eduonix course, Learning to Program with Python 3. In today's lesson, we're going to be talking about packages and modules, and how these are the ways that Python allows us to organize the code that we write into sort of different groups and files. But before we get started with packages or modules, we're going to do a quick review of the object-oriented programming concepts that we looked at in the last lesson by taking a look at a really quick example, and then we'll get started. So let's go ahead and do that. So in the last lesson, we talked about the concept of inheritance and overloading. So inheritance, once again, just for review, is how you bring in other information to a class. You can inherit methods and properties about a class, and when you inherit them, they become part of the new class that you're working on. And overloading allows you to take something that you've inherited from another class and change it completely. But you can also preserve the initial behavior like we looked at. So we're going to really quickly write up a small example of how you might do that. A kind of trivial example. This might not be a case where you specifically need to use inheritance, but just a quick example to demonstrate, once again, the concepts that we looked at in the last lesson. So let's go ahead and get started. So if we need to write a program to store contact information, we might want to have a base class that stores some information about contacts. So we can start by starting to write a really basic class. So in our class, we are going to write a simple init function. So remember, this is what gets called when you create a new object based on the class, and any parameters that you pass in, you have to specify them here. So our base contact will take a first and last name, since that information might be common to all contacts. And this is kind of how we'll get a general idea of why inheritance might be important here. So we take in a first and last name and store them as properties on the class. We use self to create a property and get some information from our variables and put them in there. So to start, that should be all the information that you need to collect. A basic contact will have just a first and last name. We can create one more variable, and let's call it contact info. And it'll just be a string that we add together that will be the first and last name together. So if you want to print that out, we can do that. I'll add a space in between the first and last name. So what this allows us to do is obviously create a function that just prints this information out about a contact. So now we have a first and last name variable passed in by the user, a full information variable that's a combination of the first and last name string, and a function that just prints that information out. So this might be base functionality for a contact. If you need to access the information, you have a way of doing so by printing the contact, and it stores some really simple information. So where inheritance might come in is you might want contacts for different purposes in this particular program. Say you're writing this program is something that's going to be a contact list for several different applications, like phone or email. So you're going to want ways of adding additional information on top of the basic contact, but you still are going to want some of the same core functionality, like all your contacts are going to want a first and last name. So this is a really perfect use case for inheritance. This is a scenario where you want to preserve some behavior but add something else. So we can do that. So let's create a class to store email information. So that's more specific than the contact. So we can inherit from contact and then add something additional. So we use the parentheses to denote that we're inheriting from the contact class. And then we write another init function. So just like before, our init takes the first name and last name. But now we're also going to have it take an email. So this is the reason why we need to write a new init and not just let the original one be used. Because if you had the same exact information, you don't need a new init function. You could add a different function or different functionality instead of just init. So what you can actually do is call Supra and use that to call init. And all you need to do is pass it the information that our Supra class actually has. So this will set up our contact with a first name and last name without having to reassign those properties, because we're accessing the init function of the regular contact class. And then we can assign the email, since that's not in the regular context class. This is the new thing that we're adding after inheriting from contact. And we might also want to reassign what the full information string is, because we have some extra information now. So we might want to add email to that. So it could be first name plus last name plus email. Or let's just use the email in this case. So the way that this will work is that you'll still have access to the print contact function, but it'll do something completely differently because we've reassigned what that variable is. And this is kind of an example of the way that you can use inheritance to, you have something that's in the Supra class that you want to use maybe in a different way in your child class. And you can kind of use this to preserve information between the two classes and maybe use a function to do something different in our child class. So as is this, you can create instances of this email contact class and it'll behave exactly the same way as the contact class does, but with extra information. So we can start up our Python interpreter and make sure that that's the case. So we can create an instance of the email contact. And we still have access to all the functionality that we inherited from the parent class. So as you can see, the email gets printed out when we call the print contact function, even though we did not have a print contact function in our child class, just in the Supra class. So this is just a quick review for us to take a look at the concepts of inheritance once again with a different example, making sure we kind of can see how we can get attributes and methods in our child class from the parent class. Alright, so now that we've reviewed our object-oriented programming concepts a little bit, we're going to move on to talking about modules first. So a lot of times when you're programming, you're going to want to organize your code into multiple files. If you have a lot of functions or functionality that's all related, you can move it into a single Python file and then use that file inside your main Python program. We generally call, when you group functionality like that together for a particular purpose, in programming we refer to that as a library. So you might have for instance, a library that takes care of math, and you can bring that into your main program and use it and use the functions from it. So Python actually has built-in libraries or modules that we can bring into our Python programs and use some predefined functions from there. So modules are how we can organize our code, and we can split our code into multiple modules and then do what's called import those modules into our main program. So first, let's take a look at how to use import, and then let's take a look at how we can write our own modules. So Python actually has built-in modules. There's functionality that's not part of the core Python interpreter, things that you can't access when you load up Python. But Python has built in so that you can import it if you need it and use it. So let's take a look at how you actually import something. So for instance, Python has a module that has some information about math-related functions and some math constants that you might need. So you can bring that into any Python program that you want. We're going to do that in the interpreter session, but the same would work if you wrote this code and saved it in a Python file. So we use what's called the import statement, and then the name of a module to bring it in. So we're going to import that math module. The name of it is just math in all lowercase characters. So we can bring it in like this. We just type import and then math. And now we have access to that module. If we type the name math, Python tells us that there's a module math that's now imported that is built in. So before we type the import statement, however, that math module wasn't loaded into our interpreter. For instance, if I reload this interpreter, and type math, even though the math module is built into Python, I have to import it if I want to use its functionality. So let me do that. So modules are objects in Python, and we can kind of get at anything that's part of a particular module in the same way that we look at what's part of an object. We use the dot to denote that we're trying to access something that's an attribute of a particular module, whether that be a function or a constant. So for instance, the math module has a pi constant stored as part of it. So you can access that as math.pi. So it's important to remember that this math module that we've imported is just another Python file. This one happens to be built in and have some functionality that we can use in the interpreter. But you can create your own modules really easily, and we'll look at how to do that in a second. But in addition to constants stored as part of modules, you can also access functions. So the math module has a factorial function that you can access using this dot notation. And you can just call it like this, like any other function you'd have. So modules can store both attributes like constants and functions. So let's take a quick look at the import statement in depth so we can kind of get a close look at what it actually does. So like we saw in the Python interpreter, the import keyword just brings an existing Python module into your current interpreter session or program. So you can use it in your Python program when you write and save it, or in the interpreter like we just saw. It allows you to bring that particular module in, and you can access that module's functions and attributes in the way that we saw. And a module, just to reiterate, is just a Python file. So when we head back to Python, we'll take a look at how we can save code in a file and then import it ourselves and access it in the same way that we were for the built-in modules. So you can use import in the way that we saw in the interpreter, and when we go back we'll look at this second way that you can use import by starting it with the from keyword, which allows you to import a specific function or attribute from a module. So in the same way that we had to namespace it with the dot. For instance, if we wanted to access pi from the math module, we had to use math.pi. If you use from, you don't need the dot, so you can grab a specific thing. If you just want one thing from a particular module instead of the whole module, you can say from module name import this specific thing. And you can get multiple things. You can use a comma and put as many things as you want there. So let's take a look at doing that. So we're going to start up a new Python interpreter session. So math is not imported, but we're going to import the specific pi attribute from math and the factorial. We'll do them both with a comma so we can see what the syntax looks like. So we start with from, then the module name, and then the things that we want to import. Each one you use a comma after. So we'll import both factorial and pi. And then we can access them like they're regular variables we defined in our program. And we can also use factorial. Okay, cool. So now we can take a look at how we can create our own modules. So all you really need to do is create a Python file. So let's create a new file and write some functions in it and make sure that we can access them. So we can write some functions in here. I'm just going to write some of the basic math functions that we've used from earlier. And we can define some variables. And that's really it. We can define all of these things in this module and then save it. And then create a Python file, which will be our main program now. And go ahead and import that module, which should just be the name of the file. And then we should be able to use the functions. Let's print these out so we can see them when we run the program. So that should be all you need to do, and you should be able to run your program. And as you can see, even though they weren't in the same file, the functions that you wrote and were able to import were loaded into your Python program. So modules are a way that you can kind of organize code and group certain functionality together. Because if you start writing really large Python programs, it's going to become a little unwieldy to have all of it in the same file. So you can use whatever organizational pattern you'd like to group your code into files, and you can import them wherever you need them. Alright, so we've taken a look at how we can write our own modules and import them into our Python programs. And it's really simple. And the same goes for packages. So packages are just collections of modules, a bunch of Python files that you might want to organize together in a single folder and be able to import them all. So you'll be able to access them in the same way that you can access attributes of modules, But in order to create a package, all you need to do is create a folder, put a special file in it called _init, with 2 more double underscores, just like the init function of a class, and then include your Python modules in there. So let's go ahead and do that. So in order to create our own package, all we need to do is create a new directory. We'll just call that my package. And then we're going to go into that directory and create our special file that's called init. And once this is here, this is officially a Python package. So we can add a module to it, something that we can import. Let's add 2 modules. One that has some functions and one that just has some attributes. So we have a module with some functions in it. And then a module with some attributes in it. So we're going to change directory out of this directory into the one above it so we can access the package. It's important to remember for all of this stuff that your modules and packages need to be in the same directory that you're in, otherwise you won't be able to access them. And we can run a Python interpreter session and then import a particular module from our package. So then we can use the functions. And so in addition to being able to import our functions, we can also import our attributes. So as you can see, you can create your own package, have as many modules as you want in there, and access them really easily with the import statement. So that's really it for modules and packages. There's nothing extremely complex in using the built-in modules or using external modules that you've written for your Python program. They're just a way to organize your code. In the next lesson, we'll take a look at how to connect with the Python ecosystem and get modules from the Python community and install those and use those in our Python programs. So that's it for this lesson.